Swayam Prabha. Digital India. Educated India.
Reverse current is due to the capacitor, and capacitor does not have a resistance path. It is having literally a short circuit. If at all something is limiting the reverse current, that is only the on-state resistance of the thyristor. There is nothing else, no resistance in the path. So the reverse current can be enormously high, and because the reverse current is high, when you look at the subtraction of the forward current from the reverse current, the net current happens to be reverse, which is not being allowed by the device, so the device just goes off. After the device goes off, the circuit will be somewhat like this. So this is M. M is gone off. Now I'm going to have this as plus, this as minus. This is my auxiliary thyristor, and here is the load. That's it. This is the circuit. Right? Freewheeling diode is there, but freewheeling diode nobody could care, because currently this is the least resistance path. So it is going to charge the capacitor. The capacitor voltage was originally like this. Slowly from that it will come to, so this is old polarity. Now this is the new polarity. So slowly the load current will try to reverse the charge across the capacitance from this to this. But in the process, definitely it will go through a zero. Right? So this is the voltage. Now it is going to be a linear kind of charging. If I assume that the load current is fairly a constant, maybe RL load with inductance being pretty large, so I'm going to have a linear charging. So this rate of rise will be corresponding to I load. Right? I load times T. That is what will be the charge accumulated. Right? So I am going to have actually from this point until this point only, I am going to have the device reverse biased. The outgoing device is M. That will be reverse biased only as long as the capacitor voltage is in this polarity. Slowly it is going from this polarity to the upper plate being positive and lower plate being negative. So only from this point until this point, M is reverse biased. After that, M will not be reverse biased anymore, because it will have a very nice conducive voltage with anode being positive and cathode being negative. So this time has to be greater than the turn off time or the recombination time that is required by the device. Right? This is clearly, governed by the equation CV equal to IT. So I can say T equal to C times delta V divided by I. What is delta V? Delta V will go from, this is, if I say minus VDC, from minus VDC it will go to 0. That's all. Only until 0 it will be reverse biased. The moment it crosses 0 it will be forward biased again. So I should say this delta V corresponds to VDC. Right? And I corresponds to I load. If I say I load is fairly constant or approximately a constant. Right? So this is going to be, if I say that, for example, there is a 100 volt supply and 10 ohm resistance with a 10 millihenry or 20 millihenry inductance, large enough to make the current fairly constant. So 10 ohm resistance and 100 volt supply, 10 ampere could be the maximum current, nothing more than that. So I load could be only 10 ampere, not more than that. So 10 ampere, for 10 ampere, I can calculate capacitance value. Delta T will now correspond to the turn off time. This has to be, slightly greater than turn off time of the device. So I have two equations and two unknowns, L and C. So I should be able to solve for both. So one is dependent upon the reverse biasing time of the main thyristor which is going off, and the other one is depending upon the pi root LC, which is the half cycle time of the LC circuit. Right? Any questions on this? Is this clear? If I am connecting that to VDC through the resistance initially, right, the current will cease to go through the capacitor after it reaches VDC. If I assume R and L, the voltage can be more than VDC. Right? Because the inductance will try to, make the current run for longer. If I assume that the load, this is not I load, I am talking about the slope of this is I load. Slope is I load. I am talking about basically the charge accumulation will be linear in the capacitor if I assume that the load current is fairly a constant. The load current is fairly a constant, then I will have the current going through the load will be charging the capacitor. I hope so that I have mentioned. If I have not mentioned, then it's not. I should say highly inductive load with a resistance component of so and so. If I say highly inductive load, it is a given that the load current is devoid of ripple. It will not have ripples. The ripples can be neglected. And in most of the motors and other things, we do have the current oscillating very slightly because we will try to make the frequency of the chopper quite high that it will not have sufficient time to come down and go up. So it will just go through like this, very, very small oscillations. That's the reason. We will anyway look at choppers also. So everywhere machines will creep in a little bit, not too much, but yes. Let us say, now why wide pulse is needed for triggering an SER, right? That's what you are asking. So let us say I have a single phase fully controlled rectifier with the resistance and a battery. So current may not be continuous if I am talking about a large battery voltage. Maybe I am talking about a 230 volt supply, AC supply, and the battery is of 220 volts magnitude. So what I have as the voltage is 230 volts RMS, of course. So here what I have is, let us say, a 220 volts battery. So if I am drawing the waveform, I should show it somewhat like this, right? So this will be about 325 volts. The peak will be 230 multiplied by root 2, which is 325 volts. So I am talking about 220 volts as the battery voltage, so it may be somewhere here, right? So if I am choosing some alpha which is around 30 degrees. 30 degrees will be 325 divided by 2, 0.5. Sine of 30 is 0.5. So I may be actually trying to trigger it somewhere here. This is alpha equal to 30. So I would again try to trigger it here. Right? If the current had been continuous, here the device will get triggered. Not a problem, because only the supply voltage will matter. But if the current had not been continuous, basically this will come as the open circuit voltage. No current is flowing. So in the cathode I am going to get this plus 220 volts. Right? Because there is no current flowing. It is open circuit. There is no resistance drop, absolutely, because there is no current. So the 220 volts will come here, and I have to look at what is the voltage here. That voltage is 325 divided by 2, because sine 30. That is only around 160, 165 volts, nothing more than that. So obviously this particular device is reverse biased. It is not going to get fired even if I try hard. So how do I give it a chance to conduct? I'll give it a chance to conduct only if I give a wide pulse. So I try to give the pulse starting from here. I say alpha is 30, all right, but if the device is not able to take over, I may start from here and I'll give until this portion. So I give a 180 degree pulse, 180 degree wide pulse to fire this SCR, but I can't give a DC. I told you because pulse transformer is being used, so I do the high frequency ANDing and so on. Now it will be able to fire at this point. If it is not fired at this point, it will at least fire exactly where the two are meeting with each other. For example, whatever is the 220 volts battery's value and the sinusoidal voltage that is coming in, if they are exactly meeting with each other at that point, at least I will start slowly forward biasing the device. So that device will get fired after this. At this point, it may get fired. So I would like to give it a chance. And for giving it a chance, especially in a battery charging kind of circuit, it may not happen in something else where I will not have any DC voltage which is coming up in the cathode of the device. This will come very clearly even in a DC motor drive. Back EMF is there. So back EMF is definitely going to reverse bias the device if I don't fire it at a larger value of AC voltage, especially without continuous current. When there is discontinuous current, I have to worry about the two values of voltages, which is higher and which is smaller. I have to compare the two. So in this particular case, it will start conducting only from this point. And then it might probably end conduction somewhere here. Possible. Right? And it will repeat itself again. So it may again start conducting from here and so on. This is how the current will. So when I have a battery, things become a little difficult for the devices to get into conduction. You don't require a wide pulse if you are sure that it is going to be continuous conduction. But who will give you assurance? You get my point? See, normally what happens is if it is a 220 volts battery, under completely discharged condition, it may have a value of 208 or 210 volts. And you might design your rectifier in such a way that it will give around 215, 220 volts. So you will put a current limiting resistance normally to make sure that the huge current does not flow through the battery. But you have to limit the value of the current to whatever the battery can withstand. So initially the current will be larger. After it gets charged more and more, from 210 it will go until 220. When it goes very close to 220, the current will become extremely small. When the current is small, it has to be discontinuous. because the inductance stored energy will also be minimal. So it can't be continuous. So we generally say there are two modes of battery charging. One will be constant current charging, which is initially done when the voltage is very small for the battery, minimum value of voltage, minimum charge condition. Constant voltage charging when it is almost full. So there are two modes of charging we normally adopt in battery: constant current charging and constant voltage charging. Right? So there is no guarantee that it will be continuous current. It heavily depends upon the state of charge of the battery. What is the charge that is already accumulated in the battery? You don't need, but you are never given a guarantee. His question is, if you are sure that it is continuous current, why do you need 180-degree pulse? But you don't need, agreed. But you are not given any time an assurance. Because you are given a rectifier. You may use it for battery charging, you may use it for DC motor drive, you may use it for nothing. So it depends. So when you design, you generally design for a general case. Right? Thank you.